Hello, everyone. Once again, welcome to the PDB Art Exhibition 2021. Before we start, I just want to remind everyone that the meeting is being recorded and the recording will be made available later. So you will have a chance to go through the full evening event. And throughout the meeting, you will have an option of Q&A at the bottom. At the bottom of the screen, and this will allow you to present your questions anytime during the event. We will collate all these questions and send you the answers either in our Q&A session or through the text. So also, this is a very social media friendly event, so feel free to use social media. We use hashtag PDBArt for our Twitter account. So do use that when you're capturing your reactions or thoughts to promote the event or congratulate the students on their amazing work. All right, to begin with, I would like to introduce myself. I am Deepti Gupta. I work for the PDB and I'm a scientist at PDB and also lead the art project. Next slide. I also lead the PDB Art Project. The PDB team is a group of scientists, bioinformatics, and software developers. We, along with our partners, manage the Protein Data Bank Archive, which is the world's single resource for protein structures. And these structures are very crucial for scientists to look for answers to important biomedical questions relating to disease or metabolism or drug development. So through the PDB Art Project and other training activities via the public engagement, we highlight the importance of these molecular structures in the PDB. And we try to make this accessible so that people could use data for their research or for their study or for anything. And the main objectives were to do more outreach, and PDB Art Project is for that. So I would now like to ask Joe McIntyre, who is our Associate Director at EMBL EBI, to say a few words and open the exhibition. Over to you, Joe.
Well, hello, good evening, everyone. It gives me a really great pleasure to introduce this year's PDB Art Exhibition. It's one of the longest running projects at the EBI in public engagement and art. And firstly, I'd just really like to congratulate everybody who's been involved in this year's program, because it's been done completely virtually with all kinds of other pandemic issues going on. So it's really fantastic that this has happened, and I'm really looking forward to seeing the art. Just to remind everybody that the PDB is one of the databases at the EBI, the European Bioinformatics Institute, just south of Cambridge, which is a world leading source of biomolecular data. And we contain information on all kinds of species, their genomes, chemicals, proteins, and indeed the structures that we see in the PDB. And you can think of it really as like an enormous sort of digital library for biomolecular information that anybody can access. And indeed, millions of researchers around the world use our resources. And this is like a key part of our mission, is to really make this data available to everybody who wants to have a look at it, in order to maximize the amount of research that can be done to benefit humankind. And a key part of that is actually training people to work with the data and understand and analyze the data so that they can contribute in the future to major issues that we're facing as the human race. So this exhibit is about data visualization and the link between science and art. And one thing I wanted to say is that data visualization is a really incredibly important for humans to make scientific judgments and insights. It's really very difficult for humans to make good scientific discoveries by gazing at massive spreadsheets of numbers. It's just too hard to take in. And so what we need are ways to sort of see the data in a different way. And this means not just science, but also other fields of study like art and psychology and computer science and human interaction with computers. And all of it comes together really in a synthesis to do better data visualization. And this multi-pronged approach is really important for coming up with solutions to tackle the global challenges such as climate change and pandemics. And indeed, we've seen in the last 18 months that people from lots of different fields and backgrounds have had to come together to come up with a pandemic response. It's not just about the science. We need creative people from all kinds of different backgrounds and educators and teachers and doers of all kinds to contribute. It really is a shared endeavor. And of course, a major part of that is the need to engage young people with science as early as possible. And this is why we work with schools to try and convey how exactly exciting science is and the need to take a multidisciplinary approach to putting science in the right context to solve real global problems. And we really want to show, to inspire and show different career paths that might be available for when, for when you leave school, and also to show that the subjects that you study at school are actually connected in the end on some level. And one of my last things I want to say is that I think, which is what brought me to biology and probably brought a lot of people here on the panel to biology and will bring you to biology, I hope, in the future, is that biology is absolutely beautiful. You only have to look around you to see the beauty, and indeed look at a molecular level, and the beauty is still there. And I think the PDB and the way of visualizing protein structures is probably one of the most satisfying visual manifestations of molecular biology that there can be. And it really, when we can look at things in that way, it really does allow us to gain new insights. So this project, PDB Art, really does help us share that beauty with other people. And this is just a really valuable, not only useful thing, but an enriching thing. And I really look forward to seeing the art in the exhibition. So thank you. And over to the next speaker.
Thank you so much, Joe, for your kind words. I hope you enjoy the exhibition and you like the artworks. So the next section of the event is to give you a quick introductory tour to the exhibition, so that you get a chance to see some of the artworks that the students have created this year and explore the themes they have used. So if we can have the video, please.
Welcome to the PDB Art Exhibition 2021. The PDB Art Project is an outreach initiative involving 8 schools, 2 art societies, and the Protein Data Bank in Europe. We work together to inspire school students from 11 to 17 years old to learn about the 3D molecular structures in the PDB and use these to inspire the creation of artworks as part of their art curriculums. Students learn to explore and research their protein of interest to create artworks accompanied by scientific descriptions, which are showcased in this exhibition. This tour will introduce you to some of these artworks made by these young artists despite facing the challenges of COVID-19 last year, while maintaining exceptionally high standards of their artworks. For second year in a row, we saw the involvement of an international school, Wellcome College, from Melbourne, Australia. This was possible and all thanks to our collaborator Dr. Onisha Patel, who introduced Year 11 students to protein structures in the PDB, inspiring them to create their own artworks, which are seen in this exhibition. This artwork from Mia Douglas Mueller investigates the biological connection between dinosaurs who lived millions of years ago with the present-day rooster, as they both shared the same protein collagen, which is found in our bones, tendons, ligaments, and skin. Composed of 3 chains wound together in a rope-like structure, Mia uses this to make the connection in her artwork called Have We Met? Year 12 students from the Lee School in Cambridge each picked up their own topic of research related to a protein structure. In this artwork from Miranda Fordham based her research on tears and the enzyme lysozyme, which is found in our bodily secretions like tears, saliva and milk. It was the first antibiotic to be discovered that prevents us from bacterial infections. It is also the most common protein found in the PDB. Being a small, stable enzyme that crystallizes so easily makes it an ideal protein for research into protein structure and function. In this piece, Miranda represents tears using a watery image and combines this with imagery that highlights the defensive nature of lysozyme. Year 7 and Year 9 students of Thomas Gainsborough School created their own artworks using the theme of petri dishes. They chose proteins like hemoglobin from giant tortoise, sperm whale myoglobin, troponin, serum albumin, fluorescent protein, and many more to create their own colorful designs and styles. They learnt about techniques like tie and dye, sewing, and acetate printing of their chosen protein structures. This artwork from Sienna Hammond, a Year 12 student of Lee School, is called Deterioration. Sienna researched the topic of aging and found inspiration for her artwork from rheumatoid arthritis, which is a debilitating condition that causes joint inflammation and pain. Through the artwork, Sienna creatively illustrates the physical changes and difficulties one faces with old age. This year, for the first time, we saw the involvement of Saffron Walden County High School in providing artworks for the exhibition. Each student from Year Group 12 investigated their own protein of choice from the PDB archive and created artworks depicting them that are showcased here. Here, Joshua Winley finds inspiration in HER2, a protein involved in cancer. His inspiration is really touching and has a very personal story, as he lost his father due to cancer in 2019. Through his artwork, he says he has learned a lot about HER2 and cancer as a whole, and finds beauty in his artwork while portraying something so emotional. At Peirce School in Cambridge, Year 9 students learnt about biology and structures of 3 proteins: hemoglobin, keratin, and salivary amylase. The students used this knowledge and explored through the PDB archive to create artworks in their art lessons. They choose to create many different forms of artworks using prints, etches, ceramics, and Photoshop that are showcased in this exhibition. Alicia, a Year 9 student of Peirce School, found inspiration for her etch from the blood protein hemoglobin that she was studying as part of her biology lessons while creating her artwork. Having an interest in science, she really enjoyed learning about the 3D structure of hemoglobin and made this as the centerpiece of her artwork. She also depicts the red blood cells and other items linked to blood, such as syringes, plasters, blood donation bags, and a test tube in a doctor's hand. A heart was also etched in the middle of the structure, signifying the importance of hemoglobin in blood, as well as highlighting heart being central to pumping blood to the whole body. Year 8 students from Thomas Gainsborough School explored the photo-switchable red fluorescent protein found in sea anemone. These proteins can fluoresce, yet have the ability to switch on or off when excited by light at a certain wavelength. They have the classic beta barrel fold with a chromophore in the middle, which is responsible for light emission, and it is also referred to as a light in a can. Fascinated by its structure and function, students created the final 3D sculptures using mixed media made of colored paper, plastic bottles, and split pens. This paper sculpture was created by Joy Morelli, who found this protein really interesting. and also learned that proteins come in different shapes and structures and that each one is unique. Here, Alex Webb, a Year 9 student from Perth School, was inspired by the enzyme salivary amylase and used this to create his ceramic piece. Salivary amylase is a primary enzyme in saliva that breaks down carbohydrates into smaller molecules, like sugars, to help our body digest starchy foods, such as potatoes, rice, or pasta. Alex based his piece on a water droplet of saliva with long, thin, pointy ends. He used a grey-green Selden glaze, but added a chun glaze to give a deep dark blue color with white specks that appear to sparkle. This brings us to the end of the tour, and hope this has given you an insight into the types of artworks created last year by these fantastic artists. So please browse these at your leisure to find even more about the wonderful artistic interpretations of science and the PDB. If you would like any further information about the project, then please visit us at our website pdbe.org/art. Thank you.
I hope you all enjoyed that video and it gave you an insight about the artworks which were produced last year. I am now really delighted that we have got two great speakers among us today. And it gives me a great pleasure to, and we are very, very fortunate to have an eminent scientist, Professor Jane Richardson from Duke University, USA, who is among us. She's also known as the mother of ribbon diagrams because she pioneered and showed us how to represent the protein structures. And we are still using the same method today to visualize the protein structures. She was also among the first scientists who described many common features of the proteins, and also she's well known for the work in protein structure validation, and she also serves as a prominent member of the PDB X-ray validation task force. So over to you, Jane. We would like to hear about your experience as a scientist and artist, and we hope everyone would really get more inspiration from your talk. Thank you.
Thank you very much, and I'm really glad to be here. The exhibition is marvelous, and it's so neat to be able to see all of them instead of just the calendar. That's very exciting. So let me see if I can share my screen and get going. So I want to talk about art and science and communication in a lot of different ways that I've used and seen over the years. And this is a shot from an exhibit we had at the main Duke Library, where I found out that ribbon diagrams go really well with Gothic arches. That was quite surprising. But that was one of the nicest features of the exhibit, plus a lot of scientific details and also details about how the ribbon representations were developed. So sort of the conceptual summary of what I'm going to try to present is that, of course, we all get started in this kind of thing as scientists in order to understand what we're doing ourselves, to understand our own scientific research and to explain it to our colleagues, and then often get involved in broader communications to the rest of the community. And also, I think one thing that good representations, which really are a kind of art, are involved in science is that a really great image can either overturn an earlier concept or support an old one or support the new one. And I'll give you a few examples that I think are pretty prominent in that range that would have been much harder to have happen without really great images. And then the kind of art that the students here are working on, I think, is also extremely important. That connecting to the rest of the world, connecting to them, but also connecting to other people who aren't scientists, to make art that really has an emotional involvement in the concepts, and possibly just the elegance, possibly disturbing, but very often really delighting people. And someone who's been delighted by a scientific concept is much more apt to be open to really thinking about it. And I think that's been extremely important in these last 2 years, and that I hope maybe some of these people will help us do better at that, where I don't think we've done as well as we could have. So to go back a long, long time ago, to the 60s and a little bit the 70s, all of this time I've worked with my husband Dave together, and we started off doing protein crystallography in the very early days of it. We did about one of the first 12 structures, and then another one in the first 20 of really different proteins. And things were amazingly primitive from the point of view of now. We did have computers that could help us really process the data from these structures, but we didn't have very good ways of showing them. So this is a brass model put together by hand of our first structure called staphylococcal nuclease. It was a cleaver of RNA and DNA as an enzyme, and came from the Staph aureus organism. And it has been used a great deal as a model of protein folding, actually, which is why we did it. So this just sort of looks like a confusing bird's nest or something. It really is hard to make sense of. It's almost as bad as the tables of numbers, a little better. And so we were doing a brief postdoc after Dave finished up his PhD degree with Chris Hanfinson, the Nobel laureate later, who was really studying protein folding and one of the most influential people early on to say that the information to fold up a protein is encoded just in its sequence, at least a lot of the time. And so we wanted to really be able to understand and show this protein better. And he suggested that we tie 1/4-inch Tygon tubing along the model and then turn on UV lights so you can see the tubing that follows the single chain through the protein. And then if you turn off the room lights, you get something that looks like a simple computer illustration, really. So we start back in the back at the top and wind around through all of this. There are 3 alpha helices, and there's a primitive beta barrel, and then a calcium and an inhibitor that are shown in red. And we put numbers on it so you can tell where you are in the sequence. And so this is still very primitive, but it's a whole lot better than what we had before. And then I made a drawing of this to try and make it understandable in 2 dimensions. And it's a really, really primitive drawing, one that we call a worm drawing. And then gradually worked over several years, really, learning how to draw them better, to really show the 3D depth on the 2D page, because at that point we had no interactive computer graphics. And so this is our second structure, copper zinc superoxide dismutase. And I'd learned how to make much nicer drawings by then. And this is just to show some of the conventions. Helices are thin ribbons in the spiral. And I learned how to exaggerate things in order to get people to really see them on the 2D page. And so the foreshortening is really more than you would get in a photograph. And then drawing beta strand arrows and making them look realistic when they turned over. I had a terrible time getting the arrowheads right. I would erase those multiple times before they looked right to me. But I think beta structure is just gorgeous. Really, really my favorite elegant kind of protein structure. And then in order to make sense of the loops, they need to be smoothed. In helix and beta, successive peptides and peptides across between strands of a helix or strands of a sheet hydrogen bond to each other and stay coplanar. And you want to really show that. But in the loops, nobody has ever found a really good way of showing all those little twists and turns. And so they're almost in all of the programs, as well as by hand, they're smoothed. And so eventually I took the step of actually using pastels, which are a pain in the neck because it's so hard to keep them from getting smudged, but they really are a wonderful medium. And this is my favorite drawing. It's of a protein called triose-phosphate isomerase, where the green strands are a big beta barrel in the middle of 8 strands, and they're always twisted. That's part of starting from handed amino acids. So the very building block chemically of proteins has a certain handedness that's almost always true in living things. And that ends up producing this twist, which is really much more pleasing than if they were just straight arrows. Anyway, the central barrel of 8 beta strands, and then it's surrounded by 8 alpha helices shown in brown. That, of course, the backbone ribbon leaves off all the side chains on the proteins or on the nucleic acids. Our lab is also very fond of RNA, which I'm not going to talk about much, but it's also extremely elegant and interesting, and enough different from proteins that you learn a lot by looking at both of them. And it turns out that the topology of this is very regular. You go up in one strand, you go down in a helix, and you connect to the next strand, and then you go up and down and connect to the next strand all the way around. And one of my favorite accomplishments ever is that this was Wikipedia picture of the day on November 19th, 1909. So that's sort of my apex, I guess, of drawing ribbons. I'm very glad that I don't have to anymore. My eyes are not good enough, and they're over 180,000 in the PDB now. So Dave and I also went in another direction that I think was a very useful visualization, which is what we call all atom contacts. We were early in trying to design proteins when it basically didn't work, at least not very well. You could design approximate structures, but they didn't act like native proteins. And in trying to find what went wrong with them, we tried to get a system. Well, we did get a system that really looks in detail at the tight interactions between the atoms inside the protein. And they can either be really favorable, like a hydrogen bond, where the atoms, a hydrogen overlaps with what's called an acceptor atom, like an oxygen, and it makes a favorable contact that holds them together. And then there are van der Waals contacts that are good touching, and then they're bad things. Sometimes the model is wrong locally. You can't actually push atoms inside each other. They're not hard spheres, but they're closer to it than one might think. And so we find problems with these things occasionally. These structures are some of the best, most reliable things in science, but they're not perfect. So we got into looking at how to make them better. And in the
I am terribly sorry, Jane, but the time is for the talk is finished. So if you could just wrap up quickly. That would
okay.
be
So these detailed structures showed how important hydrogens were to people. They're one of the places where I think they overturned an idea. And I think David Goodsell was another one that really turned around an idea. He convinced both the scientists and everybody else that cells were really crowded. They weren't a dilute solution of things wandering around. And then there are just some very elegant computer graphics around. But the thing that, of course, I want to end on, this is not from one of these art projects, it's from another artist that I met in New York, but she's illustrating the violent emotions of a man who's had a stress hormone. And this is the picture of the stress hormone doing it to him. And this seems very similar to some of the older artworks in this project, like this one about proteins connecting and in the brain and otherwise, and people connecting. And then just some amazing artwork of a snake toxin and tree rings being mirrored in the protein. Anyway, I would like to see and hear more about the current artworks. That's what I'm really excited about today.
Thank you so much, Jane. This is you have brought back memories of older artworks to the audience, and these are some of the marvelous pieces which the students created in the years before. But your talk is really inspiring, and I think you have done so amazingly. I don't have words to describe, really. Because we still use those ribbon diagrams. What would we do without those ribbon diagrams? I have no idea.
Somebody else would have come up with something.
Yeah, thank you so much. And I would like, if anyone wants to ask Jane any questions, please ask through the Q&A at the bottom. There is a box at the bottom you will see in your windows. So we will put those questions to Jane in the Q&A session. So thank you so much, Jane. I would now like to introduce Shamita Sharmacharja, who is a curator at the Wellcome Collections. She has also worked previously at Whitechapel Gallery and Tate Modern. And we are so lucky to have you, Shamita, over here. And because Shamita has worked on various programs of Wellcome Collection, she has curated diverse topics such as forensic medicine, play, and graphic design. It would be great to hear from you, from the art, from your art background, to know how can you connect art and science better. So over to you. Thank you.
Thank you very much, Diti. And how amazing to follow Jane as well. Those drawings are extraordinary and really beautiful, and yeah, very inspiring. So it's great to see those. So I'm just going to share my screen now and show you some images from Wellcome Collection. Okay, so as Deepti mentioned, I'm a curator at Wellcome Collection, which is a free museum and library in central London. It's called Wellcome Collection because it's part of the Wellcome Trust, which is a global charity that supports science to solve the urgent health challenges of our time. Both the collection and the trust were founded by Sir Henry Wellcome, who was an American pharmaceutical entrepreneur who came to Britain in the 1880s to establish Burroughs Wellcome, which was a drugs company. So along with his business partner, Silas Burroughs, Wellcome marketed and developed the tablet form of taking medicine. So before then, pharmacists had to grind medicines into powder, and there was no way to ensure purity or quantity. So as you can imagine, Wellcome made quite a lot of money from inventing tablet form. And with this wealth, he became a really avid collector of objects and books relating to the history of science and medicine, but also art and anthropological objects. When he died in 1936, in his will, Henry Wellcome left provision for a museum of mankind to house this collection, which went through various iterations before you see this museum here on this slide. I'm just going to go straight into kind of what I do as my job. So basically, I work on temporary exhibitions at Wellcome Collection, which generally take a theme or relating to health or science and show a range of different types of objects to explore it. So these include artworks, historic documents, contemporary research science, and scientific instruments and specimens. So we're a museum of health and human experience, and we work in this cross-disciplinary way to look at the personal, social, and cultural aspects of science. And in the same way as lots of your artworks in the exhibition, really bring science into a human range and relate it into to our everyday lives. So the subjects of our experience have been as varied as shows about sleeping and dreaming, skeletons and brains, consciousness and happiness, which is our current exhibition at the moment. But I thought I would just talk about one of the exhibitions that I worked on recently, and just explain how I work with artists and scientists and artists who work with scientists to build the shows that we show at Wellcome Collection. So I'm quite interested in thinking about actually the similarities between, oh, sorry, can you go to the next slide, Sarah? Thank you very much. So I'm actually quite interested in thinking about the similarities that artists and scientists have in common, what each can bring to each other rather than what sets them apart. Because when you think about it, art and science are both ways of exploring the world around us and our place in it. And both involve experimentation and sometimes failure. Both are open processes, and both really change the way that you look at the world around you. So this is an exhibition that I worked on called Forensics, an Anatomy of Crime, which took us on a journey from the crime scene to the courtroom and looked at how forensic evidence is collected, analysed, and used on the way. And before working on this exhibition, both myself and my co-curator, Lucy Shanahan, didn't know anything at all about forensic medicine, other than what we knew from watching the occasional crime drama. We both have backgrounds in art, but worked with scientists to learn about the subject matter and spent about 4 years developing the show. We worked with a coroner who advised us on its content and introduced us to a range of different science and medical professionals working in this field, from entomologists who are scientists who study insects to facial reconstruction artists and blood spatter experts. Can I have the next slide, please, Sarah? Thank you. So you can see here some of the types of objects that we had in this exhibition. So we had some body specimens, we had a mortuary table, and case notes from a really famous pathologist called Bernard Spilsbury, who was working in the first half of the 1900s. The causes of death that he lists in his notes include rhubarb poisoning and death by dry shampoo in Harrods. Forensics could be a really gory subject matter, but what myself and Lucy really learned from the scientists is that forensic medicine isn't really about death, it's about the living. And so the people who lost their lives, left loved ones behind, who wanted to know what happened and for justice to be served. So we really wanted to show this human aspect of forensic medicine, and that's where the work of the artist became really important in the show. So we had a lot of contemporary art in the show, including the piece that you see on the left, which is by a Scottish artist called Christine Borland, who worked with a facial reconstruction artist to create where she reimagines what the work looks like, what the person looks like, and what her story was from being from information gathered from the skull. We also worked with a Bosnian artist called Shayla Kamaric, who worked with scientists from the International Centre for Missing Persons in Bosnia to search for people who went missing during the war there, which happened in the early 90s, so maybe your parents would remember it. She created an installation in a mortuary fridge, which when you walked into it, you saw all of the DNA data that was being collected by scientists studying mass graves in the area, but also alongside images and videos of people who had gone missing. It was an incredibly sad and moving work, but also really powerful in seeing how science can help restore justice for the people who died. I'm actually going to skip on 2 slides now, Sarah, to, if you don't mind, just do the next slide and then the slide after. That's it, perfect. So I'm going to change now to talking about a very different exhibition, which formed part of a year-long exploration of human consciousness. So it's just a single artwork called Yellow, Blue, Pink, and it was by an artist called Anne Veronica Janssens, who is fascinated by perception. Can I have the next slide, please, Sarah? So she filled one of our entire galleries, which is about 400 meters squared, full of a densely colored mist, which changed color as you moved around the space. Color perception has long fascinated neuroscientists, and in Anne Veronica's work, you kind of experience why. Can I have the next slide, please? This is a montage of lots of photos of the installation. So basically, you're in this space that was really disorientating, and you could only really see about 1 meter's distance away from you. In fact, we actually had to install infrared cameras to find escaped toddlers in space. But by stripping back the sensors, it really caused us to experience what it is like to really to think about our perception and give a heightened awareness of inner processes that happen within our brains all the time. So I think something that I really love about this work is that it doesn't just illustrate science, but it embodies it. It's in this kind of space where arts and science meet that this kind of magic is created, with both giving substance to the other. And I think that's really kind of where my interest lies, in seeing kind of how art and science can come together and create something that is bigger than each of them. Thank you very much.
That's great, Shamita. So nice to see the connection between art and science, and so varied form of art you present at Wellcome Collection. If you have any questions for Shamita or Jane, please use the Q&A box and we will post it to the speakers. For the second time in 2 years, we have collaborated with Onisha and the Wellcome College in Australia, and they have created some amazing pieces of art and shared some views on the project. So if you could play that video, you could all see and enjoy.
Over the last 2 years, I have collaborated with the PDB Europe and Wellcome College to bring the PDB Art Exhibition to Australia for the very first time. I initiated this project because of my own interest in science and art. And through my school visits, I was interested in getting students and teachers excited about what molecules that make up life on this planet, from viruses to humans, look like, and why is it important to know their shape. And PDB Art Exhibition is a great way to educate and communicate these concepts.
I remember the wow factor moment in class really clearly when students were first able to see a protein for the first time from all these multiple viewpoints and using different visualizations. They were actually really surprised and hadn't thought about science as having that much beauty before.
What I really found interesting about this project was that students who generally are not into science or don't see themselves as science students were able to experience science through art.
I've never been one who is fond of science, and to be quite honest and frank, I wasn't too excited at the beginning of this project because I was just thinking I have to combine one of my favourite subjects, art, with my least favourite subject, science. So I wasn't too sure how the result would turn out. In fact, I was pretty scared of what I would come up with. But since the project was mentioned and to the end, I grew to actually really like it.
I like previously really loved science and art, so this project was really a great way for me to reinforce my learning in both subjects and bring them together.
The most interesting thing was researching the protein that I picked. I quite enjoyed finding out about how the body functions, how proteins help the body work, and finding out how my body in particular works too. I wanted to find a protein that directly related to my experiences. I have congenital anosmia, which means that I was born without a sense of smell. I wanted to explore the protein that detects smell.
I'd already previously been interested in antimicrobial resistance and, how bacteria work to combat antibiotics. I thought it would be interesting to, further investigate and, further my knowledge on the subject and see how I could depict it in an artwork.
Researching different proteins to find the one that struck interest in me and using it to create art, which is something most people can appreciate, is what I enjoyed most about this project. I found the protein structures particularly interesting because I wasn't aware of how artistic and aesthetic they can look.
Something I loved most about the project was that I could show my friends who didn't like science at all my art, and they would become so interested in it. And that was just so great because it meant I had used my art in a way that made scientific ideas a lot more interesting. And that was really, really great to see.
I found that science and art are both subjects that can be appreciated. And although one is built on logic and the other is built on creativity, there are many opportunities to convey any kind of concept through art, even one based on science.
It was a pretty thoroughly interesting experience. I'd recommend it to anyone who really has an interest in both or either art or science. I'm very happy to have taken part in it.
I always thought as science and art as two separate commodities, and no way they could have ever related to each other. But since working on the PDB Art Project, I've come to the realization that they in fact both work together to enhance each other. And they can be characterized by our curiosity with the world around us. So science is used to understand the world and everything that is in it, while art is used to express it and express how we feel about the things around us, both internally and externally.
This year, PDB is turning 50, and I'm really excited to be part of this community, not just as a scientist who is using the PDB database, but also using my skills to share this excitement with teachers and students. I want to thank the PDB Europe staff and the teachers that I collaborate with to make this a success. I really hope to expand this further in Australia. I hope you all enjoy this exhibition, and I'm very much looking forward to seeing it myself.
I hope you all enjoyed that video from Wellcome College students and teachers and Onisha. It gives us so much pleasure to see what the students think about the project. Now, this is the Q&A session, and we have one question for Jane, and it is from one of the attendees. It goes like this. I have a question about structures being distorted from reality in the images to make a scientific point. You mentioned that in the early days of protein illustration, there was sometimes a need to distort the image to make a scientific point clear, like foreshortening the helices. Do you think it is still a good idea to make these distortions, or do you think that this is no longer acceptable and the images should always be scientifically 100% accurate? Jane, what would you say?
Most of the distortion that I put in was very tiny. For instance, in order on a flat screen, for people to be able to follow the chain reliably, I had to make very tiny offsets so that the eye would follow them. Those were very small. The perspective issue is an interesting one because I don't like to use perspective on 3D computer graphics, but a lot of people do use it. And your consciousness of the object changes whether you are orthogonal projection or perspective projection. But mostly these days, the best graphics are interactive 3D. Now you can't quite do that in a paper, although nowadays you can put movies at the ends of them, and watch in YouTube or wherever it is that you want to see things. And so the real question is whether you know enough to turn things the right way or whether the movie is good enough. It's very rare that you actually have much distortion or any even in the computer representations. Now, there is another point, of course, that I mentioned about whether everything in the model structure is correct. That's a separate issue. And then in artworks, very often you're using the image as a symbol rather than the exact details of it. And so there you're certainly allowed to distort things. And I think maybe different sorts of points would want either fairly accurate images or very distorted ones.
Thank you, Jane. We have a question for Shamita. How do you see art and science collaboration evolving over time? How important are collaborations between scientists and artists?
Well, how can I see them evolving over time? Well, it's quite interesting now that people are using different technologies and working together. So VR, for example, virtual reality is being used more and more by artists, which I think gives a different kind of connections with them, I guess, processes which feel imperceptible or invisible. I think that that's really exciting, a way that artists and scientists can perhaps work together. But I think with connections between artists and scientists, I think that they'll always be there. I think there'll always be ways of exploring the world together. And I think that actually, in my job, I've noticed more and more kind of science museums and medical museums popping up all over the place, which I think shows that there are quite a lot of there's quite a lot of interest, I think, in people working at this intersection.
Can I put a comment? I think it's gotten more acceptable to do this recently.
You are absolutely right. I think we see that connection more and more nowadays through art and through other things. It was never there before, like 10 years ago, but now you hear about science and art everywhere. Yeah. In the interest of time, I would say that if you have any questions, you can post to us on the chat, and we will try to get back the answers from the speakers through other forms that we can get in touch with, like Twitter or social media. But I would really like to thank Jane and Shamita for giving us time for the exhibition opening, and it was really great to hear from both of you. So we are delighted that you could come to the show and opening the PDB Art Exhibition. So thank you so much. I would also like to thank Joe McIntyre, who took time to welcome and talk about the EMBL's objectives about public engagement. So thank you, Joe, for opening the exhibition officially. I would also like to thank Venue AV in terms of organization, and also Connecting Science public engagement team, who have supported us enormously in not only running the project, but also behind the scenes with a lot of logistics. So thank you so much. Also the EMBL EBI Comms team, who have been such a great support for the project in all terms, and they have promoted the project so well that we could not have done it ourselves. So thanks to Bryony and Oana, you are the most wonderful guys we have worked with. Thank you so much. We also would like to thank the funding organizations, EMBL EBI, Connecting Science, and Wellcome Trust, in providing grants to run the project. Without this, it would not have been possible to, to work with the schools and inspire school students to, for taking up science in the future. We would also like to thank teachers and schools who were involved in the project, especially the teachers who have taken up the challenge in showing the structures to the students, and talk about the PDB and all the wonderful protein structures to them. We would also like to thank the students themselves who have created such great pieces of artwork this year in spite of facing the challenges from COVID, being in lockdown and not able to do the usual classes. So a big hand to the students for creating such wonderful pieces of art and learning about the protein structures in the PDB. So thanks to you. If you want any more information about the PDB Art Project, we would like you to go and visit on the website pdbe.org/art. We also have a mailing list. If you want to get in touch with us, it's pdbart@ebi.ac.uk. And we also do a lot of public engagement work, but the Connecting Science public engagement work team do more public engagement, and they have a lot of programs there that run on the campus. If you want to get in touch with them, then you have the email address. We also have a lot of social media presence. And if you want to get in touch, please use any of the channels. And we will, we will get back to you. So before we close the event, I would like to thank everyone who joined us for the opening, and would like you to go and visit the virtual exhibition. The link is over here for you. And thank you so much, everyone, to attend the event. After this event is finished, you will get a survey. So I would like you to please give feedback about the event itself and what you liked as part of the evening today. We hope to see you live sometime in the near future, but this way is even better because we can reach to even more people around the globe. So thank you so much for your time. I hope you had a wonderful evening. Thank you. Bye-bye.